Hello everyone, let's now go over the split array harder problem that you were assigned to solve, and I hope you had a chance to really give it a try on your own. Even though you may not actually get a perfect solution, don't feel frustrated. It's a challenging exercise, so at least you get very aware about where you might get stuck, either at the planning stage, thinking stage, or coding stage, or tracing stage. Doesn't really matter, so at least you know where the gap is. So let's now try to fill out the gap for you. I'll try to keep the current video not too long, so I will just try to highlight the trickiest part for you so that you can get through your learning. And then you want to remember that the first half about your learning is definitely to comprehend the solution of the split array harder. Of course, my solution is just one possibility. You can feel free to be more creative and maybe try to play with the solution and try to come up with yours. That's definitely fine. But the second half about your learning process is actually equally important. You want to make sure not just to comprehend the solution, but also you want to be able to recreate the solution on your own from scratch, so that if I give you a similar problem at a similar level of difficulty later, so you will be able to solve it as well on your own. It's a very important learning process for you. So just getting the solution and try to somehow understand it is not enough. I cannot emphasize this more. Alright, let's now take a look at the projects and then remind you a few details, and then we'll go ahead and code up the solution and talk about it. So you already know how to download this split array harder starter, and then if you click on recursive methods here, and we're going to talk about this public method here, split array harder. And of course, this current parameter design would not be sufficient for us to run the recursion. So we're going to define some private recursive helper methods, which I will show to you. And as for the details about the problem description, I'll give you some very quick recap, but you still gotta read the details, right? That's important. I may not spend the time in the video. Alright, let's now remind you very quickly about the assumptions and also details that we assume. So I assume that you already studied very thoroughly about the split array problem that we discussed earlier, because the current one is like a natural extension to it. So make sure you review this problem here. You can find the problem description, you can find the starter code, you can find the solution from the 2101 lecture site for winter 25. You can just go there and search for that. And let's now recap very quickly about the current problem that we are solving. So we are trying to extend a split array problem. I call it split array harder. And the return type or the output is going to be, rather than a simple Boolean value, is going to be an array list always of size 2. Alright? So there are two cases over here. Either if the split is there, or if the split is not there. When the split is actually possible, in that case we assume the split is going to be exactly one, unique. But if you want to make the problem a little bit more challenging for yourself, you can also, let's say we relax this assumption to say the splits might be multiple, in which case how can you store all the splits in your return type, right? That's something you can think about. But let's focus on the current problem, which is challenging enough for many of you, right? Let's assume the solution is going to be unique if there's any. If there's an equal split, then the return array list index 0 is going to store group number 1 integers, and index 1 is going to store group number 2 accordingly. If there is no such split possible, in that case you're just going to store empty lists in both indices. You're still going to return an array list of size 2 no matter what, but just that both groups will just be empty when there's no such a split. Let's look at some example. Okay, example number 1, you got input array 2 2. Apparently the split can be 2 and 2. So the return value is a single array list. At index 0 we got 2. At index 1 we got another array list of size 1 but contains 2, right? So here we got 2 3, in which case there's no split possible. We still return an array list of size 2. Index 0 empty list, index 1 empty list. And let's say we got 5 2 3 as the input. And in that case we got we got the output array list of size 2. Index 0 is going to be the group number 1 split, which will be 5, and group number 2 will be 2 3, which is also another array list. You always return an array list of size 2, always. Finally, you got 5 2 2. There's no equal split possible. In that case, just like this case, you still return an array list of size 2. Index 0, index 1 are both empty lists, representing empty groups. that's a very quick recap about the problem. If you still have doubts about it, you can go back to the starter code and read through the description there. And you may also want to look at the JUnit test cases to really see what the expected output is for each like a input, example input, right? Take a look at this one as well to understand the problem. All right, so let's now try to code up the solution in Eclipse. We'll go to the recursive methods class over here, and then you can see at the moment the public method just returned null. You know, just for our affirmation, let's just make sure nothing works. Make sure. All right, just yeah, you can see all the test cases fail, right? And if you are wondering about how to run the JUnit test case, you can just right-click on the recursive methods test under JUnit package, and then say run as JUnit test, right? Just be sure. Okay. All right, let's now go back to here and let's try to code up the solution in Java. And let me maximize the window over here. Okay, so you feel a little bit more comfortable. And let me try to also centralize the coding area over here. Okay, let's now take a look. I'm going to actually compare this extended version of the splitArrayHarder with the simpler version of splitArray. They actually share quite a bit of the code in common. They share quite a lot. So I'm just going to give, as I type, I'll also give you some hopefully comments or some verbal comments as well, so you can also take a notes. All right, so let's now start with this. Okay, so what we'll do is we're going to eventually we want to return an output of this particular type, array list of array lists, which we already talked about. So I'm going to say array list, which is already imported. If you're not, you got to make sure you import the array list, right? You can see it's from Java util over here. All right. The array list itself contains array lists, basically, right? You can think about the E over here should always be the member of or elements of a single array list. And now we're saying that each array list that's returned contains array lists as its elements. So we're going to say array list over here, and each element array list contains integer representing the groups. So here we're going to say integer over here, right? That's how you understand the nested types over here. Output will be assigned to new array list. Here we just say that initially just empty. All right. And you can also refer to the tutorial video that's actually in your lab instructions about how to use array list. There's some tutorial for that. I assume you should also catch up with that if you got any trouble understanding. So eventually we're just going to return the output over here. Right? We'll just make sure everything compiles. And then we're going to see how to set up the output over here. So the idea will be we're going to exploit the idea about call by value. The idea will be we want to pass the reference to this particular output variable, which is a reference variable, is referring to an object. We're going to pass the output so that it can be shared among all the recursive call. And when we trace all the recursive call, it's going to boil down into some tree structure. And then at every layer of the tree, the output is somehow going to be shared. And then we'll try to add the two groups into the output whenever we find that we have found a split. Of course, if we don't really find a split, the output should just contain two empty lists. That's something we should do. All right, so what I'll do is I'm just going to show you how we can somehow pass the recursive call. So now what we need is a recursive helper method, because the current method here, just by calling the recursion on that, is not going to be very, very useful. You need some extra parameters to really help you pass around some information that's going to be shared among the recursive call. That's really a design pattern you have to really keep in mind whenever you want to think or program recursively. So the recursive helper method I'm going to introduce will be some private one. In general, you can introduce as many private recursive helper method as you like, but for now we just need one. And that one there is just going to be void. Typically, if you want the recursive helper method to return void, that means you're going to maybe do something or modify the parameter using call by value, because the parameter that we're going to see is going to be of reference type, and call by value can make sure because you share the reference, you can just modify the objects using the reference from different recursive call, right? So that's why returning void over here is actually appropriate. You don't really need to say for recursive helper method, I want to return just the same type. Not necessarily. You might play with it to maybe you want to try a different version that can make it work. But I would say in this particular problem here, making the recursive helper method returning void is the easiest solution to understand, right? Using call by value, it is so important, right? Let me just write it down here. Using call by value, the output is going to be shared among all the recursive call. This is not the only variable that's going to be shared. There will be a few more, which I'll show to you. All right, so let's do the void method here. Let me just call that split array harder helper. All right, so that's the recursive helper method. And if you recall the easier version without, the easier version just split array. The parameters are still applicable over here. So we still need the input array ns, and also we need the current index that we are looking at, which elements in ns that we're inspecting. And also we got integer sum of group 1, integer sum of group number 2. So these are the parameters that you kind of needed when you solve the split array, not the harder version, the split array simpler version. But we're going to introduce extra parameters in this case, right? So what I will do is I'm just going to say comma over here, and then I'll change it to a new line. So starting from this line, these will be the new parameters or extended list of parameters that we need for solving this problem here. So I want to keep track of which I want to keep track of the two groups, group number 1 and group number 2, they are members. So each one of them is going to be an array list, right? Just the element type right here, right? I can just copy that. So this will be group number 1, and also I got group number 2, and then I also want to share the output over here, right here, right? So I can also copy just this part here. I'm going to make output also a parameter, right? So these are the 3 extra parameters that we will need in this recursive helper method in order to solve the problem. All right, right here. All right, so let me just write a little bit more comments, and then we'll try to right now it's having some yellow warning over here because we haven't used it yet, but I'm gonna use it. All right, so let me make the recursive call here. So split array harder helper, right? And very conceivable, we're gonna say ns starting index for I should be 0, and the sum for group number 1 and group number 2, the next two. So these two should be, let's say, 0 to begin with, right? They may be accumulated later. 0 and 0. Right? And then we're gonna have the group number 1 and group number 2. So here you got choices. You can maybe try to create 2 empty array lists before that and pass these 2, pass their references. That will be one way. But if you want to save some lines of code, you can just use anonymous objects, which I'll show to you. Anonymous objects are simply objects without any references, and which you learned from the previous Java course. So I can say new array list, right? So this is 1. You might be wondering, should I also pass integer over here? Strictly speaking, you don't really have to, because somehow Java compiler can figure out that since you're passing this new array list, actually for the 3rd parameter over here, it can figure out that you really meant array list of integer. All right, so that's just something for you to know. But if you want to put integer here, that's fine too. All right, that's 1. That's for group number 1, and here I'm going to say group number 2. All right, and then finally, I will also need the output, which I already initialized right here, right? I'm going to pass that as well. So our assumption is, among all the recursive call as we trace the tree, all these 3 variables somehow will be modified using call by value. All right, so let me finish that, and then we can go ahead and code out the details for the split array harder helper using call by value. So there are 2 aspects over here. One is about output, and also the group 1 and group 2 are also to be modified by different recursive calls. However, I want to make another insight. This insight may not make much sense at this point, but once we start tracing, you will see exactly what I meant. Okay, I would say note. The way we are going to accumulate the group number 1 and group number 2, right? These two, which will be the two array list. The idea will be we're going to accumulate these two almost on every recursive call, almost every level. However, you're only going to modify the output over here when you pretty much reach the bottom of the recursion tree, meaning that when you're already reaching the base case of the recursion, meaning that you already decided whether it's going to be, you have already found the split or you have not found a split, right? It's very important. All right, you know what? This might be the best way to put the comments. Okay, so for this output over here, the output should only be modified using call by value when we reach the base case where we know for certain whether split is possible. Right? When I show you the base case, you will see what I mean. On the other hand, for group 1 and group number 2, whenever we want to make a new recursive call, we have to update group 1 and group 2. Remember possibility number 1 or possibility number 2, right? When an element may be either put into group number 1 or put in group number 2. Each possibility is going to correspond to a separate recursive call. Okay. These two variables are expected sum of these two, either 1 or 2, right? Either one. Sum of these two variables is expected to be modified whenever a new recursive call is made, right? So guys, so remember these two insights are very, very important to understand about the pattern, which I'm going to show to you, right? May not make much sense right now, but once I finish the solution and do some tracing, you can revisit these 2 points. All right, let's now continue. The way we're going to make the recursive calls is going to be very similar to how we deal with the simpler version. Basically, again, you gotta consider both possibility. Whenever you're considering the current elements at index I into array ns, you want to consider either that elements at index I is included in group number 1 or the element is included in group number 2. You got a binary choice there, right? The same principle still applies in the challenging version. It's just that somehow you got to keep track of exactly what the members are rather than just deciding true or false. So what I will do is I'm just going to write something down over here. I know that eventually I'm going to, okay, how about this? I'll show you a little bit more in a way that's a little bit more intuitive for you, right? Rather than just throwing sequential lines to you. I know that I need to make 2 recursive calls, all right? So one will be possibility number 1, another one will be possibility number 2, right? Possibility number 1, we agree that it should be I plus 1, right? That one we already explained for the simpler version. And we're somehow going to say sum of group number 1. In that case, that'll be one possibility, so plus NSI, right? And also sum of group number 2 over here. But the tricky bit is about group number 1 and group number 2, right? I'll get there in just one moment, okay? For now, I'll just say group number 1, group number 2. And then I'll talk about conceptual level first, and then we'll talk about how we should do it in Java to make sure it's correct. You can, oh, by the way, you can see that right now everything's just compiled. You can see the splitArrayHarder helper, since it returns void, we don't need to say anything like a return. So this here is this right here is different from the splitArray simpler version, right? Just notice that, right? So this will be possibility number 1. Possibility number 1, NSI is included in group number 1. Of course, right now you can see conceptually we're not being consistent just yet. Somehow I add NSI to sum of group number 1, but I did not somehow pass the group 1 that's being updated. So this group number 1 is still the old one without the extension of NSI, since now we're considering that possibility, right? That's something I'll talk about. Just give me one moment. For now, what about I just say this will make it not compilable, but I'll just say plus. That means group number 1 somehow has to be extended with NSI. Okay, that's what I meant here. But let's just write it down. The other possibility as well. And then we need to set up something programmatically to make it work. All right, so we got possibility number 2. That means NSI will be included in group number 2, right? In this case, we're going to do something very symmetrical. So NSI is not going to be extended to group number 1. Instead, group number 2 will be extended right here. And then we got to add a sum right here. All right, just say plus right here. All right. So this part here about sum of group number 1 plus this and sum of group number 2 plus this. These two parts you already know from the simpler version. So what we need to understand is, what do I really mean when group number 1 is actually extended with some element, in this case NSI, in group number 1, or in this case extended to group number 2. Naively, you might be thinking, can I just say group number 1 just add NSI? This conceptually may not be too problematic. You're just thinking that, oh, at this point, since I know I need to pass maybe some extended version of group number 1, so I'll just add NSI into it. However, this will turn out not to be working programmatically because, briefly speaking, but I can visualize this when I get to the tracing. You want to make sure individual recursive call do not really interfere with the group they are dealing with. You want to make sure everything, every time you're receiving a new group, is more like a new objects. So whatever possibility you're really considering, either go for possibility number 1 or possibility number 2, is not going to impact the same object that's being shared by other recursive call. Right? It sounds a bit tricky, but that's something you will have to also experiment yourself. So I would suggest, I'm going to give you the correct solution that can avoid the problem caused by aliasing. But later on, you can also go back to this version here and give a try to see how it might fail the test cases. That's also a very important exercise for you to know in order to understand everything that's contained in this example. Right? So the correct way, let me just say this. This is not going to work. First of all, if I simply say group number 1 over here, okay, I'll give you a little bit explanation here. This is because the same reference to group 1 is passed to the next recursive call. However, when the next recursive call is phasing again the possibility of including NS, of course the next one will be I plus 1, right, into group 1 or group 2, we just cannot let the two separate recursive call, because we got two possibility, the two further recursive call interfere with each other by sharing the same reference group 1. All right, I think that's pretty complete explanation, but if that doesn't make sense to you, you got to see the tracing first before you can appreciate that, right? But I'm going to leave the explanation here for you, right? It's actually important insight. So what we'll do is we're going to say group number 1 plus over here should be a new object that we're going to create. Let me call this one here group number 1 extended. So the way for you to create a new array list is by just calling its one of its overloaded constructor, right? You can look up the API yourself. So I'm going to say array list of integer and then group 1 extended, right? So that'll be new array list. So now this one here is guaranteed to be a different reference. So we're not trying to interfere with the existing group number 1, right? When we make a further recursive call. And here I can say whatever group 1 contains, I'm just going to create a new list out of it. All right. So group 1 extended, you can think about it's a separate list from the group number 1 over here. Different. All right. And let's now add to the group number 1 extended. This is not what we can do. All right. So rather than group 1.add over here, we can now say group 1 extended.add. Group 1 extended dot add NSI. So guys, a very important exercise for you. This here, these two lines are the correct solution. However, I really want you to think and try to go back to this wrong version and figure out exactly why it wouldn't work. But explanation and hints are here, right? Important exercise for you. So that's possibility number 1. And we do possibility number 2 in a very similar way, right? So I'm just copy these two lines, and then I'm just gonna create group 2 extended. Right, so gonna create that out of group number 2, right? Just make sure you change that one. And also group number 2 extended should be extended accordingly, of course. And now we got group number 2 extended. All right, we're almost done. So now you can see we nicely lay out the code for recursive call possibility number 1 and the recursive call for possibility number 2. And the idea would be we want to make sure the output will be somehow properly updated when we know that there's equal split. But that would be the base case. So far we're just coding up the recursive case directly. But this part here should be somehow separate from the base case, which I'm going to do, right? So what I will do is, let's now code out the base case. So base case, we know pretty well from the simple version, if I is ns.length, that means we have inspected all the elements in the input array ns. In that way, we got to check to see whether the two sums are the same. If the two sums are the same, that means we have found the split. Otherwise, we have not found the split. As easy as that. So we say if sum of group number 1 equals sum of group number 2, if that's the case, we have found a split. In that case, we know that the group number 1 and group number 2 so far must have accumulated the correct members in the group. So that should really represent the correct split for us to return ultimately. So I'm just going to say, so this will be the only point where I try to modify output. Remember the insight I talked about over there? Let me revisit very quickly with you. This output list may only be updated when the equal split is found. So this is exactly the timing for updating the output list. This is the only place where we update the output rather than in each recursive call. We only update the output when we reach the base case. As easy as that, right? You gotta make sure you also clarify that for yourself. So I'm gonna say output dot add group number 1, and also we're gonna say output dot add group number 2. All right. So this will be the recursive base case, and then I can make it a little bit cleaner. Else will be the recursive case, right? So I can simply just copy, just select, highlight this part over here, and then you can just cut it. All right. Give me one moment, and then make sure indentation is right, and then you can now paste it. Right. So now we got a nice base case right here, and also recursive case right here. All right. However, right now it's still not exactly right. Right. If you try to rerun the test cases, it's still not green bar. Okay, we're getting very, very close. All right, so I'll just show you the fix right away. All right, the fix will be, let me just double check over here. Yep. So there's 2 more things I gotta do. Number 1, so you can see that when we first pass the output over here, it's simply just an empty list without any members in it. And we nicely add group number 1 and group number 2 when we actually found the split, right? However, what about the case where there's no split? If you remember right here, exactly these cases, right? If you look at right here, you can see the case where we have no split for 2, 3, and we have no split for 5, 2, 2. We still need to add the empty lists over here. That's something we're kind of missing, right? So let's now try to go back here. So we add some if conditional here, right here. So we're going to say if the output dot is empty, that means we never reach this if conditional here to really add group 1 and group 2. That means we never found a split. In that case, we just add an empty list right here. So you can say output dot add a new array list, right? You can put integer if you like, but if you don't put it, Java compiler will be able to figure that out. But I'll just put it here for you. Right? You can see here we just added the 2 empty lists corresponding to the two empty lists right here, one here and one here. All right, that's a special case we gotta deal with. Output being empty means that no equal split has been found. All right. However, if I run the test case, we are okay. So now we are good. So everything is working. But is everything really working like what the green bar is showing? Let me see. Let's see together. So I'm going to draw your attention to one of the test cases, let's say for example, and everything else will be something similar, okay? But let me just get to, let's say we want to have a split for 5 to 3, for example, over here. So the result over here should be like a split between 5 and also 2, 3, right? Over here, right? So what I will do is I'm just going to put a breakpoint. You can do the same to reproduce what I'm doing now. Put a breakpoint right here under test split array harder 03, test case number 3. And then I'm just going to launch the debugger right here. Okay, debug that test case. All right, of course, it's going to ask me to switch to the debug perspective. Let's do that. Okay, if you got any red line like this, don't worry, it's not an error. All right, so right here. So now we are pausing at line number 43 right after executing the split array harder input, right? And we are basically trying to compare group number 1, group number 2 over here. But I want to draw attention to the following, okay? So what you can do is you can see under the output, right? Output here is actually an array list. However, if you look at that here, right? 5 and 2, 3. So these are the two splits that we are expecting to compare. Exactly, right? You can see the 5 here and also the 2, 3 over here. That's good. And when you get 0 from the output, is going to get basically index 0 right here. And we are trying to get 1 over here, you're basically trying to get 2, 3 over here. However, we're actually getting some extra stuff in the output list that we are not really expecting. You can see right here, it's kind of show us 4 elements. So we also got some element at index 2 and also some element at index 3. Especially you can see that we have another 2 groups over here that we are not really expecting according to the problem description. You can see here we got the 2 groups, 5 and 2, 3, and here we got 2, 3 and 5, like the reverse order for the group. That's not really something we're expecting. That is, remember the problem description that we said earlier. The return array list should be of size 2. But right now we are returning an array list of size 4. So the the initial starter test case that I gave to you, I only checked to see whether the first element and the second element are correct. In this case, it is, right? We got 5 here, we got 2, 3 over here. However, there was a missing assertion there. That should really say the size of the return result list should be only 2. But this one here, having 4, should really fail that assumption. So that's something we didn't really do in the starter test, but now we should really somehow extend or strengthen our test cases to make the requirements a little bit more complete. All right, so hopefully you're following me. So what I really meant to do is something like this. Let me just do one and then I'll show you how to do the other ones very quickly. Just take us 1 minute. All right, so what I want you to do is hit a new line here, right? So we also want to assert, let's say assert true. All right, but assert true is actually an assertion that we have to import. If you move your mouse over, just say add the import, right, for assert true. Once you do that, you can see that at the beginning of the file, we got assert true imported, right? That's something you gotta make sure you do. And let's go back to here. So what should we assert true? We want to say the output, not only that the first element and the second element should really have the expected value, but also the length of the output list should be correct. The size, right, that's how you get the size or how many elements are there in the array list. It should be exactly 2. All right. Now, this will be some extra assertion that's going to make our test case more complete, more assertion on the output. And if I rerun the test, you can see now this test number 3 here is failing. Especially it's failing if you right click on that. So now right click, just double click on that. You can see that's bringing us to this line. So this one here is failing because size is actually 4 rather than 2, as I showed you earlier. So this is really some assertion we would like to get right. In order to get it right, we have to go back to our recursive method over here and fix it. I'll go to the fix in just one moment, but I would like you guys to do something over here for me, please. All right, so just copy this line here, assert true. We're going to update it. We're going to extend it to every test case that we have, right? Because for every test case, we always return the output of size 2. Right? Add 1 here for test 1, and add 1 here for test 2. Test 3, we got 1 already, and also add here to test number 4, and add here to test number 5, and add here to test number 6, and add here to test number 7, add here to test number 8, we're getting there, and add here to test number 9, and also add here to test number 10, and add here to test number 11. Okay, getting very much to the end. Number 12, okay, here for number 13, and also for number 14. All right, save it, and let's now rerun the test cases. And now suddenly we're getting more failure over here. All right, but don't panic. I'm gonna show you how you can fix it. But you really gotta kind of understand why we are adding these assertions to deliberately break the green bar that we saw earlier. Not just because I don't like green bar, but it's actually because we were missing some important assertion to really check the input-output relation completely. Again, you want to really convince yourself that the output size should be equal to 2. Over here, the extra assertion is necessary to really correspond to the input-output description that we talked about earlier, right? That's really important for you to convince yourself. All right, so let's now go back to the recursive methods over here, and we want to fix it, right? Let me just align well again. So now we go back to this particular helper method here. Let's see how we can fix it. To derive the fix, let's just go back to the JUnit test case that we actually are failing. So if you go back there, this was the one that we were illustrating, but the failing test right now, since we added that assertion about size being equal to 2 for every test case, there might be some earlier failing test, in which case we have to put a breakpoint and run a debugger. So let's take a look. If you rerun the test case, you can see the very first one. Oh, sorry, let me just make sure the focus for the cursor should be outside any of the tests, right? That's also important. If I rerun it, you can see the very first one that fell is the first one, right? Why don't we go there, right? So put a breakpoint right there. So we can also find some equal hints about how we should really fix the error. And once you put a breakpoint in line number 22, and then we're gonna run the debugger once more. All right, so now we are switched to the debugger perspective, but you gotta make sure maybe you can see from right here. We can see the different panels over here, or you can just do the following. You just gotta double click on the tab to maximize it, right? Otherwise you wouldn't see the variables panel right here, right? That's our panel, right? So under variables, you can see the output right here, right? You can see the split that we are expecting in this case will be 2 and 2, right? So that means as soon as the output list has been added, remember we only modify the output list in the base case, right? If you just remind yourself, if you go back to the code, we only try to modify the output right here from empty into the 2 element lists over there. We only do that when we reach the base case. So basically, after these 2 have been added by these 2 lines over here, we should really disallow any further recursive call to really continue. That's kind of the idea, right? So you want to add some if conditional to really make sure this part over here is really going to be necessary if somehow we couldn't find any equal split, maybe from the left branch. That's something you will see a little bit more clearly when you actually see the tracing. For now, I just want you to get the intuition that in order to really fix the error, you want to make sure this part of the list is not really extended. And the way to prevent that from being extended is to make sure you only make the second recursive call about possibility number 2 when necessary. All right, so that's really the idea I want you to get. Of course, later on, once we do the tracing, that can reaffirm this idea. Let me stop this. All right, let me maximize this again. So what I'm going to do will be for possibility number 2, I'm just going to wrap it within some if conditional. I'll say if output dot is empty, right? Remember the output list when I first pass that to for the very first time to the recursive helper method, the output right here is actually initialized to be just empty, right? It does not contain even the empty list, right? Just empty, completely empty. So I want to say, if from constructing the possibility number 2 over here, if the output remains to be empty, so that means I should really explore further about the possibility number 2, right? That's a very important if condition for you to write. If you don't really have this conditional, you're gonna fail that extra assertion we put about the size of the output list. All right, so let's now just put it here. All right, put it here. All right, possibility number 2. So we do possibility number 2 only if necessary. Let's go back to recursive test over here, right? Let's now rerun all the test cases, right? You can see all the test cases now pass, right? So just be sure about the 2 fixes we have made so far to the code, right? So once we have done the base case and also the recursive case from the earlier part of the video, we made 2 changes basically, right? Change number 1, we want to make sure the special case where if the output is empty, that means we have found no split. In that case, you got to make sure the 2 element lists being empty should still be added as a return value, right? Because always the return value should be of size 2. And fix number 2, you want to make sure recursively this second recursive call is only invoked when necessary. Otherwise, you're going to fail this particular assertion about the size of the output. All right. Let's now try to do some tracing now that we have already finished all the Java implementation and passed all the test cases. And let's now switch to my iPad over here. Right, so before I get to the tracing, let's now just review the code that we have developed very quickly. Okay, so we got our splitArrayHarder right here, and we got the helper method over here. And just notice the way I highlighted. So for all the gray highlights, so these are the code necessary for the simpler version of the split array. Any of the additional extension we have been adding in this current video for the splitArrayHarder, they are highlighted in yellow right here. So you can definitely compare and contrast them when you actually study for this solution here. I'm going to leave that to you. I have already explained the code logic when I was developing the code from scratch together with you. I just want to make just a couple of annotation very quickly, and then we can get to the recursion tree to really understand some test case, exactly how it should be built up, all the recursive call in the tree. Number 1, I want to highlight about the 2 array lists over here. Right, you can see we got basically this will be group number 1 right here. Right, I'm going to use the blue, and I'll try to keep the same color convention when I try to do the tracing. All right, so right here, this will be basically the group number 1. I'll just say G1 over here. And this will be the group number 2 right here. Group number 2. And then this output over here also is going to be kind of manipulated using call by value. And this one here is just for the overall return value, right? So it is important to actually, again, notice that this is only modified in the base case. In the base case, specifically when we have already found the equal split. As for group number 1 and group number 2, right? It is important for you to remember these 2 variables will be modified at every, either one of them is going to be modified in every recursive call, non-base case. So either of them modify in every recursive call, the non-base cases. Either of them modify in every non-base case or every recursive call. Okay, let me just write a little bit better. Every recursive call. And of course, they're simply non-base case. And once we see the recursion tree for tracing, it'll be even more obvious for you. All right, let's go a little bit deeper into the actual recursive helper method to see how these 2 groups of variables, you can see this is like a first group, this is like a second group, right? To see how they are modified a little bit differently. Let's start with the group 1 and group 2. So you can see group 1 here, is going to be extended, in this case, in possibility number 1. And we got group number 2 extended in possibility number 2. And as in the base cases, you can see in this particular base case, we are not really modifying group 1 or group 2, or we are not simply we are not extending them anymore. We simply pass them as is. So you can see the group 1 here is simply passed from the arguments, right? It's simply passed directly from right here. And also for group number 2, it's also passed directly from whatever that's given so far. We don't need to extend it any further because that's already the base case. On the other hand, about the output, right here, right? The output is only modified right here in the base case, whereas in every recursive call, we are simply passing whatever that's being accumulated so far. Well, to be very precise, the output list should really remain to be 100% empty until you reach the base case, right? That's something we also see. Oh, sorry. So you can see output here and also output here, right? So these are two possibilities where you don't really modify the output before you get to the next recursive call, right? It's really important to see that. And of course, all these three variables, the way we kind of modify them, either in the base case or recursive case, we are making use of the call by value concept you learned in the previous Java course, for example, 2030. So the call by value is also very important for you to review if you're still not comfortable with it, right? Call by value, right here. Call by value. All right. All right. So now that we have already made the annotations, and then we can now actually try to trace one example thoroughly and try to put everything together, and then that'll be it for the tutorial. Let's now switch to the tracing. The test case I want to trace together with you will be this one here, test split array harder 03. That's the one we also look at, right? Just remember this was the new assertion that we added right here. Okay, and here I'm using some color convention here, and I already drew the tree, so I can just go right to the point. I want to focus more on how these three variables, group 1, group 2, and also output, are being manipulated. I think that's really the most important items for you to learn from this advanced pattern for recursion. You can see we start with this particular call right here, and then we got 5 2 3, 5 2 3, right? We start with the index being 0, and then when we reach this level here, we are considering index 1. When we reach this level here, we are considering index 2, and then in the last level here, I got index 3 right here, right? I'm just running out of space, so this and this should be at the same level, right? I'm just kind of putting them, like a one above the other, just lack of space, right? Just bear with me. And then you can see that whenever I got any blue branch over here, it's really about possibility number 1 right here, right? So that's about making some change to group number 1. And also the way I drew the green over here will be about some extension to, for example, this is the green, the right hand side. That's about making some extension to group number 2 over here. Of course, this will be the entire tree that we spoke about, which will explore exhaustively all the combinations over here. However, I'm going to claim that because of the if condition that we have added, at some point, we will be able to forget about the right branch if the left branch already kind of extend the output by the 2 splits, if the split exists in the base case, right? So that's a very important insight to actually see in the trace. We'll see that as we go. All right, guys, let me say one more time. At some point, we will actually realize, for example, right here, we realize after finishing this branch, the output will have already been accumulated with the 2 element lists representing the 2 groups, in which case it will not be necessary anymore for us to explore this particular branch. But I drew that just to show to you that would be the theoretical complete set of recursive calls that you have to consider to really account for all the combinations. Okay, all right, let's now take a look and to see how things will go. Of course, we're making this split array harder input, right? Let's go right to the point right here. So what I will do is I'm going to set aside the output list. So let me put output right here. Okay, so the oh, sorry, output right here. Right, you can see when we first pass the output into the call, we are basically just passing like an empty, right? Well, of course, if you look at here, that's really where I should really go back to. So you can see the output here is simply just empty to begin with, right? And the output is going to be shared among all the recursive calls. So I'm just drawing a single copy, right here. So this will be the empty list that we are having right here. All right. Whenever we got to change it in the base case, we're going to change it. On the other hand, the two groups over here, which is also another two list, each one of them is somehow going to be somehow copied and also extended and passed around to the next recursive call, like a next level, right? That's something you got to remember. So what I will do is for group number one, in the beginning is going to be, so let me write here, okay? In the beginning, we got the group number one, which will be just empty list. Group number one, just empty. And also group number two will also be empty, right? That's how we started with, right here. Okay, so you can see that group number one right here, group number two, both being empty, right? And then in order to complete this one here, we have to execute this block of code, which will involve the first recursive call. That's what we're gonna do, right? So we're gonna go right here. Okay, we're gonna go through here. So this one will involve the 5 being put into group number one, right? You can think about 5. Let me use the right color. So 5 over here will be put into group number one. So after that, we're going to extend the 5 over here into group number one, and group number two remain to be empty. Of course, we also got group sum. For the group sum, you can think about is 5 versus 0. Right? So that's exactly what we got right here, right? The sum of group 1, sum of group 2, and sum of group 1 will be 0 plus 5, right? So that part there, maybe I wouldn't mention so many details. That's something you learn from the simpler version for the split array. All right? Let's focus more on output, group 1 and group 2. Right? So from here, so this branch is not going to be executed just yet because we're going to finish the left recursive call. In order to finish this one, we have to also finish the left and the right, right? So now for the left. That means we are looking at index 1, which would be this particular element. And we are talking about the 2 being put into group number 1. Right? That one is going to further extend the group over here by 2. So that's going to be, I'll put here, that's going to be 5 and then 2. And then the second group remains to be empty. And the sum will be 7 versus 0. All right, hopefully you're okay with that. And then in order to finish and this branch over here is not going to be resumed executing until we finish this branch, right? So now in order to continue to execute this, we're going to go for the left, which means the 3 will be put into group number 1. So that means this will be the 3 is going to be put into group number 1. That one there is going to be 5, 2, and 3. Versus the empty group still for group number 2. So that means we got 10 versus 0. Alright, so you can think about this guy here is really the base case right here, right? So what should we do in the base case? Let's be very careful here. The base case here, we're going to check to see whether the sum of group number 1 equals to the sum of group number 2. The sum of group number 1 will be 10 versus 0. They are not equal to each other. So we are not going to execute this block of code. We are not, right? So that means output should remain to be empty at this point. All right, guys, here now is a very critical point. After this base case here, I'm going to write it down explicitly. It is very important for you to note, right? Okay, so after this, the output remains empty. Right, remains empty over here is very, very important for you to realize, because it is empty still, right? According to our, well, you can think about in order to really finish this particular call here, we gotta finish the left, which is the possibility number 1, and we only go to possibility number 2, which correspond to this branch over here, if the output so far is empty. Indeed, it is empty, right? You can see it's still empty. That means we got to go here. All right. I'm also going to put here. We go for this branch because the output is empty at this point. All right. And that one there is going to be about the element, which is 3 right here. Is going to be put into group number 2. So 3 will be put into group number 2. Right? And then after that, you can see right here, so 5, 2, and then we got 3 extended to group number 2. Right? So what we'll get is we're going to get 5, 2 right here, and then we're going to get 3 over here. And what's going to be the sum for the two groups? It will be 7 versus 3. Obviously, it's not matching, right? You can see for this particular base case, they are not matching, right? Not matching. So we are not going to update output still. Not really. It's just that both this and this represent not unequal split. So now we are not going to update the output just yet. All right. So also you can think about also after this, similar comments. Output will also remain empty, right? So that means after executing this particular block, for which we have to explore both this, and both of them don't really get a chance to update the output because we got unequal split. We got 10 versus 0 and 7 versus 3, right? So now we're going to return from this. And once we return from this, we are now done with the left branch. Should we go for the right branch? Indeed, because now according to the definition, if the output right now is empty, then we can go ahead to do that, right? So now indeed it is empty, right? So we'll go for that. So we'll go for this branch because the output is still empty. In which case we're going to put in here, we are considering element 2, right? We're going to put 2 into the group number 2. So what we get is, let's be careful. So we got 5 here, not extended. And also we got 2 here, that's being extended, right? So what's the sum? So we got 5 versus 2 right here. Right, let's now continue. Now in order for this one to be continued, we got to do both the left and the right. And the left is going to be the group number 1 possibility, right? So that means the 3 that we're considering here at index 2. So 3 is going to be put into group number 1. That's going to result in, so 5, 3 versus 2. 5, 3 versus 2. That one there is going to give us a sum 8 and also 2, right? And this is a base case, obviously. And you can see after this, the output should still remain empty. Would you agree? Because 8 versus 2, right? So you can see 8 versus 2. Not satisfying this, so we're not going to add it. Not yet. All right. So after this, also, we're going to get the same comments, right? Also, it remains empty right here. So we kind of finish this, and then we go back to here. Should we continue with the right branch? Indeed, because as far as this recursive call is concerned, we just finished executing this block over here, and the output remains to be empty. So we're going to execute this block. You can see how important it is to have this conditional here. It will just make things work at every recursive level, and make sure output is really updated properly only when necessary. All right, so now we're going to go for this branch, and that branch is actually going to correspond to the element, which will be 3. And 3 should be put into group number 2, and that's going to update like a 5. Okay, let me just do that carefully. So you can see from here we got 5, and now we're gonna get 2 and then 3. Agree? So what we get is we got 5 here, and then here we got 2 and then 3. Obviously you can see that's an equal split. Awesome, right? And the sum will be correspondingly 5 and also 2 plus 3, that'll be 5. So this is a very, very promising one. Okay, so this one here is going to trigger the updates, because when we reach the base case, right, is going to see sum of group number 1, 5, and 5, right? So you can see 5 and 5. So that means we're gonna modify the output right now for the very first time, group 1 and group 2. Alright guys, let's now do something very important. So that means I'm going to add this 5 over here into the output as the first element. I'm going to add this 2, 3 list into the output also as a second element, right? Let's do that. So what I'll do is I'm going to say this one cross out. Instead, I'm going to add group number 1 right here, 5. And then I'm going to add group number 2, which will be 2, 3. Right here. So now after this point, after this, only after this, output is not equal to empty anymore. This is a very, very important point for you to note right here. It's not equal to empty, right? And then once we return to here, so now this guy here is actually going to also return because we finished both branches, right? And then we're going to go back here, and also once we get to here, we also finish both branches. Now we return to over here. We have only finished the left branch, but after finishing the left branch, we know that at the very bottom here, we have already updated the output to be something that's not empty, right? So now, as far as this call is concerned, we have already finished this part over here. And now we are asking whether we should really execute this part. No, because output is now not empty anymore, right? So it is going to make this condition here false. So we are going to bypass this. So this effectively allows us to really bypass. So we don't need to execute this part anymore. It's going to be bypassed. All right. But I should know exactly when we can bypass that. So this will be bypassed because output has already been set properly, and this is because we assume this is only a unique split for the array, if there's any. All right, bypassed because output has already been set. So the final outcome is just going to be this output right here. All right, 5 and 2, 3, and that's exactly what you will see, 5 and 2, 3 as the return value. And also you can see the size of the list is exactly 1 and 2. The reason that a previous version where we didn't have this conditional here, why would it not work? You can now see a little bit more clearly. If we didn't really have this conditional over here, that means we will still execute this branch over here, and maybe somewhere in there we're also going to get a split like a 2, 3, and also 5 in one of the base cases. You can check to see, try to check yourself to see which branch or which base case is going to give you this swapped order of the group 1 and group 2. However, these two will also be added to the output if we didn't really have this if conditional, right? That's a very important observation for you to also try to trace yourself and also to convince yourself, okay? All right, so hopefully that really makes sense to you. I think the tracing here is actually very, very crucial for you to also do on your own and make sure you're really convinced. All right, guys, let me recap very quickly. And I think I kind of promised that the tutorial video shouldn't be too long. Hopefully it's still within 1 hour. But I think I really try to omit many details which I assume you already learned from the split array simpler version. But what I really already walked through with you all the important stuff about how to use the group 1 and group 2 versus the output differently, right? You really want to convince yourself they are really the way they should be used. Oh, one more thing to say. You can see when we go from, let's say, 5, 2 and also 5, 2, 3 over here, you have to make sure whenever you want to extend 5, 2 with 5, 2, 3, you have to first of all create a copy of 5, 2 into a different list and then extend the 3 in there. So that's exactly what you will see right here. If you didn't do that, if you didn't do this kind of like a new list creation first, you're going to run into interference between different recursive call about the same group 1 and group 2. It's just going to mess up the updates between the recursive call. You're going to mess up about the considerations of different possibility and different combinations. All right, so I think one more thing I'm going to write down as exercise, and then we're done. So what you really want to complete, of course, you're going to go for the solution yourself and reach out to me if you got any question. But the exercise for you will be this. You really want to also trace what we have been doing here to see how this part here can really be bypassed using the Eclipse and debugger, right? And we already showed to you when we spoke about the simpler version for the split array, about how you can use the Eclipse in detail. So this is something I would expect you to really do on your own, right? Don't skip the exercise. It's not going to be good for your learning, right? I'm going to put it here. All right, so that'll be it. And hopefully, I hope you enjoyed this splitArrayHarder, the more challenging exercise. Study that, and then, as I said, comprehending the solution that I'm presenting to you is only the first step. The remaining half will be you have to somehow digest and also try to redo the problem on your own and make sure you are able to handle other problems at a similar level of difficulty.